Hello and welcome to the very first chapter of physics, and you can see on the screen it is elasticity. आपके मन में क्वेश्चन आ रहा होगा कि मोशन इन ए स्ट्रेट लाइन, मोशन इन ए प्लेन, न्यूटन्स लॉ, ये सब तो हुआ नहीं, इलास्टिसिटी से स्टार्ट हो रहा है। कोई बात नहीं, दिस इज इंडिपेंडेंट चैप्टर। ऐसा नहीं कि आप वो नहीं पढ़ेंगे तो ये आपको नहीं होगा, ऐसा नहीं है। यू कैन इजिली लर्न दिस चैप्टर विदाउट नोइंग दोज कंसेप्ट्स। And let me tell you, I will be taking the volume 2 of physics from elasticity up to waves, okay, and someone else will be covering your mechanics volume 1 part completely, okay. So, and from the competitive point of view, I'll not say that this chapter is too important, but I'll say definitely this is a chapter that you should not leave, क्योंकि अगर आपको इससे क्वेश्चन आए then you can easily bag +4 marks, क्योंकि ये बहुत आसान चैप्टर है। and I don't even need to make 7-8 lectures on this chapter, as it's a short chapter. 1 to 2 lectures will be enough of 40 minutes. This will be very much accurate and adequate enough for you to tackle the questions that will come from this chapter, okay. So I'll not waste any more time of yours. I'll move to the part, but उससे पहले एक चीज आप सुनो कि elasticity, why do we need elasticity? We have quite seen a few examples of elasticity in real life. You can say, आपने rubber band तो देखा है. For example, when you stretch a rubber band के ऊपर एक force लगा रहे हो, the force that is called deforming force. Why it is called deforming force? It deforms. This force deforms. This force deforms the shape and size of the body. This kind of force is called deforming force. Okay. So आपने डिफॉर्मिंग फोर्स अप्लाई किया, आपने मान लो एक्सटर्नल फोर्स से अप्लाई किया बोलो, तो व्हाट हैपेंस, द शेप एंड साइज ऑफ द रबर बैंड चेंजेस, बट you have observed that as soon as we remove this deforming force, okay, what happens, the rubber band regains its original shape and size. फिर वापस आ जाता है, अपने शेप एंड साइज को रिगेन कर लेता है. Now how this happens, we will see how this happens. But उससे पहले जान लो, this is the very phenomenon of elasticity, okay. This is what we are going to learn about in this part. So you can see, elasticity, the property of a body which enables it to regain its shape when the deforming force is removed. जैसा कि मैंने कहा आपको कि आप डिफॉर्मिंग फोर्स को रिमूव कर दो, आपका बॉडी अगर आप जैसा उसके प्रीवियस शेप एंड साइज, ओरिजिनल शेप एंड साइज था, अगर आ जाए, then that bodies are called elastic bodies and the phenomenon is called elasticity, okay. But the thing is that the body does not regain its original size and shape even after removal of deforming force. आपने deforming force को remove किया, लेकिन फिर भी बॉडी आपके ओरिजिनल शेप एंड साइज को रिगेन नहीं किया, okay. Then this kind of bodies are called plastic bodies and property of this body is called plasticity, okay. This phenomenon is called plasticity. तो elasticity में क्या होता है, बॉडी रिगेन कर लेता है अपने ओरिजिनल शेप साइज को आफ्टर द डिफॉर्मिंग फोर्स इज रिमूव्ड, बट प्लास्टिसिटी में it will not regain its original shape and size even after the deforming force is removed, okay. So I think this part is clear. So let me get into what is the reason behind this kind of behavior of matter. अब क्यों ऐसा हो रहा है, क्यों रबर बैंड अपने ओरिजिनल शेप साइज को अटेन कर ले रहा है आफ्टर remove the deforming force. Let's see. ताकि आपका टाइम वेस्ट ना हो, मैंने पहले से ही डायग्राम ड्रॉ करके रखा है. व्हाट इज दिस, you know, this is actually, you can call this thing as your unit cell. You will learn about these parts later in chemistry in solid state. This is just an unit cell, okay, and these are lattice sites. These black dots, these are lattice sites, okay, and it will represent each and every atom, okay. Each and every atom is represented by these black dots. So what happens, just try to observe that when you apply a force, आपने force apply किया, जो that is being called deforming force. So what happens, as these atoms are fixed, these black dots are represented as atoms. Okay, so these atoms, as they are fixed, as they are not bound to move, so what happens when you are applying a deforming force, this atom starts to vibrate. ये जो atom है ना आपका, ये vibration start कर देता है, and vibration जब start करता है, so supposedly it gets displaced, for example up to very short distance like this. This also get displaced up to very short distance this. Okay, now you might have a question कि इनके बीच का ये जो bond है, this bond, this yellow lines representing the bond, is it breaking down? I'll say no. ये bond आपका नहीं टूट रहा है. Okay, this bond is not breaking down because the deforming force is not large enough to break this bond. Rather, what is happening that the bodies are getting just slightly displaced from its original position as long as the deforming force is acting, because as long as the deforming force is acting, there is this vibration that is causing the bodies to get displaced from their original position. ठीक है, अब आपने deforming force को remove कर दिया. Now you are removing the deforming force, so what happens as soon as there is no force on this, these atoms shoot back to their original position. Okay, and ultimately this is how they regain their original shape back. Okay, this is how they regain their original shape back. So जब deforming force था, the atoms are getting slightly displaced due to the vibration. Okay, so there was that elongation, slight change in the dimensions of the length, and later we'll learn about area, later we'll learn about volume. Okay, so but as soon as you are removing the deforming force, what is happening? The atoms that are previously displaced are now regaining their original position back, are coming to the original position back. Thus, the body regains its original shape and size back. Okay. So I think this is clear. This is the cause of elasticity. This is the how physics explains elasticity. Okay. So let's move on to the next part. About the slight different terms we'll introduce. About, let's say, stress. What is stress? Okay, let me tell this about internal restoring force. Let's go back to the previous slide. Okay, see here, when the atoms, let's say this is our atom previously in this position. Okay, the atoms are previously in this position, and let's say now it is then coming, after you apply the deforming force, it is coming back, coming to here. Okay, it is getting here. Now what happens? What happens that the deforming force is acting towards this direction, F. Deforming force is acting towards this direction, F. But when I am removing the deforming force, how can the body regain its original position? So there must be a force that has to act opposite to the direction of the opposite to the direction of the deforming force, right? क्योंकि deforming force को जब आप remove कर देंगे, according to Newton's second law, there has to be a force that needs to act in this direction so that the body shoots back to its original position, right? होना चाहिए. So this force, this मान लो अब मैंने यहाँ पे small f कर दिया, this small f force which is countering this deforming force, and when this deforming force is removed, this small f, this force comes into play, and this force helps the body to regain its original shape back. This force is called restoring force, and as this whole thing is happening internally inside the body, this is called internal restoring force. Okay, why restoring force? As it is helping the body to restore its original and previous position and shape and size back. Okay, so I guess it's very much clear to you about what is internal restoring force. So be very careful about this thing, that stress is the internal restoring force set up per unit area of resisting area is called stress. Okay, so this is nothing. Okay, don't bother yourself too much with that resisting area, these kind of terms. This is simply, as you can see with the unit, this is simply, I can say, stress. Let me give you the mathematical formula about it. Stress will be very much is equal to your force per unit area. Okay, what is mole? Just as I said, it is the internal restoring force per unit area. And let me tell you, in equilibrium condition, this internal restoring force will be equal to your deforming force. Okay, so if in the question it says that you are applying 250 Newton force, the deforming force, it will mean that the internal restoring force is also 250 Newton. Okay, this is the way to solve the questions. So stress will be very much will be is equal to F upon A. Unit is Newton per meter square, and you know that this Newton per meter square is also called Pascal, in the honor of Blaise Pascal, right? So 1 Newton, and I guess you remember this thing, that 1 Newton per meter square is equal to your 1 Pascal, right? Okay, sorry for that, your 1 Pascal, right? Now let me tell you another very important thing, that what is it then, as I just, you can, I think you can recall that pressure also has the same formula, right? Force upon unit area. So, and stress also has the same formula, force upon unit area. So what is the difference between stress and pressure? So there has to be a difference ना, otherwise क्यों हम लोग नया term introduce करेंगे stress? There has to be a difference. See, stress is internal restoring force per unit area. This is a very important thing. This internal, you often overlook this term, internal restoring force. But on the other hand, pressure is not that thing. Pressure is externally happening. Okay. Also, pressure is always, I guess you remember, it's a normal force. It always acts normally to the surface, right? So I think you remember that, right? So this is the thing. Now, if the stress is normal to a surface, is called it is normal stress, and normal stress can further be classified into tensile stress and compressive stress. Okay, we will come later into that. We'll study about the various classifications of tensile stress and compressive stress. And another thing we will study, that's tangential stress, which is very importantly called as shear stress. Okay, we'll call about shear stress. We'll study about all these things. Okay, wait. Okay, so wait a bit, my pen was not working. Okay, now it's working. Let's see. Yeah, so we'll study about shear stress. Let's move on to the next part about it. Okay, what is this? This is strain. Now another term is introduced, strain. अब देखो strain क्या होता है? So I guess आपको एक चीज समझ में आ रहा होगा कि whenever you are applying a deforming force, there is a change in the dimension of the body, right? Maybe in the volume or maybe in the length or whatever. But there is a change in the dimension of the body, right? So strain is nothing but this is the ratio. This is the ratio of change in dimension to the original dimension on application of deforming force. This is called strain. Okay, this is called strain. Let me tell you, for example, there is a wear. Okay, let me tell you, there is a wear about it. Okay, and you are applying a force so that it is getting elongated. Okay, it is getting elongated. So there is, let's say, there is a change in the length. Change in length is del L, and this original length is L. Okay, original length is L. So strain is nothing. Strain will be your what? Change in dimension. Change in dimension we have seen it is del L, and the original dimension is what? It was L. So this is strain. This is your strain. All right. This is nothing. This is the ratio of your change in the dimension to your original dimension. Okay. So I think it is very much clear to you. Then let's come to the, as I said, we'll learn about the classifications. So there are types of stresses and strains. Okay. First comes is what? Your direct or longitudinal. And as I said earlier that it can be further classified into tensile stress and compressive stress. Okay, let me tell you about what is tensile stress and compressive stress. This is a body, okay? This is a body. For example, you are applying a force in this direction and in this direction. So you are basically trying to elongate the body. I think you are getting the feel. You are trying stretching the body. You are elongating the body. All right. So what will happen to counter these deforming forces? An internal force will be set up in this direction. All right. And here also. All right. So I think it is very clear. So this kind of stress generated due to this kind of forces when you are trying to elongate the body, then this stress is called tensile stress. Okay, this is called tensile stress. This stress generates when you generally try to elongate the body. All right, but now let's say there is this body, there is this body, and now you are trying to compress it. You are trying to compress this body. Okay, it is not the thing कि आपका इलास्टिसिटी विल ऑलवेज बी अबाउट कि आप डिफॉर्मिंग फोर्स जब भी अप्लाई करोगे तब भी आपका बॉडी इलोंगेट ही होगा, ऐसा नहीं है. आप इसको कंप्रेस भी कर सकते हो. देन ऑल्सो इफ इट रिगेन्स इट्स ओरिजिनल शेप बैक, दैट इज ऑल्सो कॉल्ड इलास्टिसिटी. ऑलराइट. So when you are trying to compress this body, then a stress is generated called compressive stress. So the restoring forces will be towards this direction. Okay, this is called compressive stress. So I guess it's clear. I guess it's pretty clear कि आपका टेंसाइल स्ट्रेस क्या है और कंप्रेसिव स्ट्रेस क्या है. एंड आई गेस आप यहाँ पे ये भी समझ सकते हो कि टेंसाइल स्ट्रेन एंड कंप्रेसिव स्ट्रेन क्या होगा. So you are applying this deforming force here in tensile. These are called tensile forces. Okay. So that there will be a change in dimension. For example, let's suppose there is change in dimension del L. So there that ratio will give you the tensile strain as well as you can get it for compressive strain also. So next we will come about normal stress and volumetric strain. Okay. So you can refer to this figure here. This was this thing, that is blue colored figure. Okay. This is your original cube. Let's say this is a cube, original cube. And when you are applying this force normally to the surface, okay, what happens? It shrinks. The volume reduces. Okay. So this kind of stress is called a normal stress. Basically, it is all about the normal force per unit area. Okay, the force is acting normal. Just as I said, it will be normal stress. And what happens as there is a change in the volume as you can see, it is changing. Here it is written V naught minus del V. This is the new volume. Okay. For example, let's say, let me tell you about this. Your original body's volume is V. And when you are applying that normal force, its volume gets reduced by del V. Okay. So what will happen? The new volume that is generated, the new volume V dashed will be your original volume minus that change in volume, right? V minus del V. So this is what it is written, V0 minus del V. Okay. So automatically, I think you can understand that there is again change in dimension and you can generate a strain. There is a strain that is being generated, which is, volumetric strain is equal to del V upon V. Your change in volume upon original volume. So it is clear. Okay. Let's see the next part about shear stress and shear strain. So refer to the figure again. नीचे वाला figure, I think you can see the figure, right? Yes, I think you can see the figure. So what is happening? Okay, let's try to understand what is shear stress. Recall that this happens due to the force is tangential. जब force आपके surface से tangential होगा, this thing happens. You will learn about this thing in fluid also. Let me tell you. For example, this is your surface. Okay, I'll try to redraw that figure again. It is clear to you. Is this okay? And let's say this is your body. Okay, this is your body. Let me tell you one thing. This part is fixed. This part of the body, this part will not move. ये move नहीं करेगा. This is actually fixed to the floor. Now what is happening? You are applying a force like this, tangential to the surface. So what will happen? The upper part will slightly move, right? The upper part will move, but this part will be fixed. So it will be like this, right? So the body will become like this, right? I think you can understand. Now let's say this part is L, original length is L, and this part is del L. This slight shift, see this part is del L, and the original length this is your L. Alright. So I think you can see what is shear stress. This is actually again force per unit area. Now this is tangential force per unit area, to be more specific. Now what is shear strain? Let me tell you what is shear strain. For example, let's just consider this angle to be phi. Let us consider this angle to be phi. Okay, shear strain is denoted by phi. So phi will be is equal to what? I think you can apply trigonometry here. You can apply trigonometry and you can call phi as your del L upon L, right? I think you can call this, right? Yes, I can be more specific. I can be more specific here. How can I be more specific here? Because it might pose a problem for you. Let me tell you that from trigonometry you can say that tan phi, actually tan phi, it will be very better to say that tan phi is equal to your del L upon L. Now you know what? In maths you will learn some approximations. If this angle phi is very small, okay, this angle phi is very small, you can consider it up to 3 degree or up to 4 degree. Then if phi is very small, then you should learn this, you should remember this, that tan phi you can write is almost equal to your phi. Okay, so we have directly approximated and written like this, that phi is equal to your del L upon L. Clear? So I guess it is easy to understand up to this. और अगर कहीं पे आपको प्रॉब्लम हो तो let me know in the comment box. Okay, let me know. Let's move on to the next part about elastic limit. What is elastic limit? This is the maximum stress within which body can regain its original size and shape after removal of the deforming force. You know, this definition will become much more clear when we will try to interpret the stress strain curve. But let me tell you, elastic limit is nothing. You know, there is a limit. This is the limit of stress, maximum stress. After which, you know, इसके बाद अगर आप इस स्ट्रेस से, मैक्सिमम जो आपका स्ट्रेस है, इस स्ट्रेस से अगर आप ज्यादा स्ट्रेस अप्लाई करोगे तो द बॉडी विल नॉट regain its original shape and size back. Okay, so elastic limit is what? The maximum stress up to which the body can regain its original shape and size back after the removal of the deforming force. Okay, this very basic thing is called elastic limit. All right. So next part is about Hooke's law. So already we have reached up to 25 minutes. I will not extend this part more. Okay, Hooke's law we will cover in the next lecture. Okay, सो अच्छा लगा आपको, और आई गेस अगर आपको अच्छा लगा सीख के, अगर मेरा पढ़ाना अच्छा लगा, तो you can please subscribe and do refer this video to your friends. Okay, so next lecture mein we will start with Hooke's law and we will cover the different parts of module. There are 3 modulus of elasticities. We'll cover those parts. Okay, so till then, goodbye. Okay, and have a nice day.